This is chapter 6.3. We'll do a quick lecture and then we will do some examples after this video is completed. So we have a truss and we already completed our lesson on method of joints. And if you think about method of joints, if we were to solve for AB and AG, if we cut this truss right here, we would be able to solve for AB and AG. That would be the method of joints. So when we're looking to find forces of just a few members, instead of the whole truss or something, we could look at using what's called the method of sections. We must know that the truss is in equilibrium. We are also still doing the same thing with our tension and compression. We draw everything in tension. When we compute our forces, if they come out positive, they're still in tension. If they come out negative, they are in compression. We'll be using our equilibrium equations, summing our forces in the x, summing our forces in the y, and summing our moment. And when we cut a truss, typically the number of sections should be less than 3 members or 3 members or less. So if you were to look at this truss that I have here, let's say we wanted to solve for BC, GC, and GF. We could cut our truss in this manner here. We could say that's section AA, and then we could draw our free body diagram of the left side or of the right side and then compute the forces. So if I were to draw the free body diagram of the left side, we would have something that looked like this. Where this is point A, B, and then this would be C here, and then if we drop our dash line here, that would be F, and this is G. So here this would, when we compute these, this would be computing of BC, computing of GC, not GG, GC, and GF. And then we'd give the distances. And we would sum our moments or whatever we're looking at. And as we do our example, that would kind of make more sense. But just looking at free body diagrams. So if we could also look at the right hand side, which would have something like this. We have this whole section, and then we would have, again, drawing these in tension. And you could also do your dash lines here, and this would be your points there. But we would also have our, this would be dx, dy, and this would be ex as well. So this would be your free body diagram on the right side, this would be your free body diagram on the left side. Something you really need to do when you're looking at these types of problems, you need to consider what equations to use to solve for what unknown is best. Try not to solve simultaneous equations. More than likely you'll be able to find one equation where you sum your forces in the y and solve for one, and you'll be able to solve for one of the members. So you will have to draw, so your procedure is you draw your free body diagram, and you're going to draw your cut sections, which is pretty much your free body diagram, and then you'll be using your equilibrium equations in order to solve for your members. And again, if it came out positive, it would be tension. If it came out negative, it would be in compression. So I'm going to go ahead and cut this video and then start the next one with example. And that example is going to be, we're going to be looking at is 6-27 in your book. And then the other example that we're going to be looking at is going to be 6-45 in your book. That way, if you want to kind of draw them out, look at what sections we're cutting, that way you have those kind of already written out as I'm going through the example, and you can follow along a little bit better. And again, I will upload my engineering formatted problems onto the content page for your viewing as well. Thank you.